வந்துச்சா? சரி ஓகே. இது எதுக்கு கிளியர் ஜாயின் அந்த நியூ சவுண்ட் நான் இப்ப எடுத்துட்டேன்னா இது மாதிரி சவுண்ட் வராதோ?
Good afternoon, everyone. Am I audible?
Yes,
Hello?
sir.
Yeah. Okay. So today is basically activity session. So let's begin with asking the question: have you, went through the lectures of week 3 yet? Have you seen all the lectures of week 3?
Yes, sir.
Okay. And have you tried to attempt the solve with us assignment or activity questions?
Sir, there are some doubts in activity.
Yeah, definitely we will discuss that. And yeah.
Excuse me, sir. Sir, just one thing which I want to ask, that while undergoing those activity questions, there are a lot of formulas involved, like integration of cos x. Then it is giving a lengthy expression in terms of log, tan, secant. So I presume that in case if such sort of questions are coming in the quiz, then obviously the formula should be provided, or we need to learn the formulas for all these integral and derivative of.
I mean, some basics formulas of integration and derivative you should, remember maybe. I mean, what is derivative of cos x or what is integration of cos x? This kind of thing you should be familiar with. But if some lengthy expression is there, then those may be given in the quiz, in the hint of the questions in quiz.
So that trigonometry identity is like cos x plus cos y is equal to 2 into.
Those kind of thing will be given. Those we are not asking in this course. But what is the expression of, suppose, derivative of sine 2x? So basically that is derivative of sine x, and then you have to derivative of 2x also, right?
Yeah, 2 cos x.
Yeah, so it will be 2 cos 2x.
Yeah.
So this kind of thing you should be familiar with. I mean the basic derivative of sine x, derivative of cos x, derivative of tan x. Similarly, integration of those things also.
Sir,
okay? Yeah.
Sir, like what we have to only study substitution and integration by parts, right?
Yeah.
Not any other type of integration.
No.
Okay,
I mean, these two are enough for this course only. Okay.
Okay, sir.
There's one more question, sir.
Yeah.
If you can explain a little bit about the global minima maxima and the local minima maxima, because while going through the lectures, what I assume is that in case if we are given an open interval, then we can go for computing of local minima and local maxima.
Exactly.
But for global maxima or minima, in case if we are given the closed interval, then that means that the function is existing at those boundaries. And in that case, if we are supposed to
You have
know
to check for the boundary points
on the
also.
boundary itself. So in case if the function exists on the boundaries, then in that case, that will be the global maxima or minima given the closed interval and the function existing in those boundaries.
Exactly. Yeah. So
Yeah,
if the
I
function,
assume that if you take any, in the meanwhile, if
yeah.
you take those
So
numericals,
in today's slides, I think there is a question on that. So we will come
fine,
to
sir.
that.
Thank you, sir.
Yeah.
Sir,
Sir,
are we going to discuss activity questions in that session?
Similar to activity question, some questions which are exactly activity question, I have picked some activity question from the lectures already given there, and some I have make some changes and given here. Okay, so those are similar to activity questions, and some questions are similar to practice assignments also. So I will try to cover all the topics in week 3. Okay.
Sir, can I ask a conceptual doubt?
Yeah. Sure.
Sir, like when calculating the local maxima minima, when the second derivative comes out to be a constant, what does it mean? Like, get
Not
confused
coming
in
down
that.
to a constant. If second derivative is strictly less than 0, then it is maxima.
So, like, if
It
it
may
is
be
a
constant
constant,
also. Yeah, -2. Suppose it is -2. Then
then
it is strictly less than 0. Then it is giving us a maxima. If
so
second
sir,
derivative is greater than 0, strictly greater than 0, then it is minima. But when it is 0, only that case we have a problem. We cannot conclude from the second derivative test in that case.
so sir, if it is a constant, there is only one critical point, right?
If it is constant, the
Like,
second derivative.
yes, sir.
That's what I am saying. It does not matter it is constant or not. If the constant itself is strictly greater than 0, then it will give you minima. If it is strictly less than 0, then it will give you maxima.
Okay, sir.
Critical points you are finding by solving the equation f dash x equal to 0, right?
Yes, sir.
So from that equation you will get the critical points, mainly the number of critical points. And second derivative test is just for checking whether those critical points are maxima or minima.
Okay, sir.
Okay. Okay. So let me
So
share. Yeah.
just one question, sir.
Yeah.
To find the area under the curve, we perform the integration, right?
Exactly. Yeah.
Suppose the function f of x is discontinuous within an interval a to b, but still we can able to calculate its area under the curve.
So there is something called improper integral, so which is not in the course, in this course, but the concept is, suppose the number of discontinuities are finite. I am talking about finite only. Suppose the number of discontinuities are finite, then we can calculate it, because for each piece we can calculate the area under the curve. Suppose I have a function which is discontinuous at 0.2, and I have to calculate the area from 0 to 5 in the interval 0 to 5. So what will I do? I will calculate the first piece from 0 to 2, then the second piece from 2 to 5. So there the number of discontinuity is 1. There is exactly 1 point where it is discontinuous. So in that case we can calculate. Okay.
Okay, that means, sir, in the integration, definite integral, there is a property. If integration a to b f of x dx, we can write the same as integration a to c fx dx
exactly.
plus c to b fx dx.
Exactly.
That means this type of function is discontinuous at point c.
No, not necessarily always. I mean, whatever you have said, this equality, integration of a to b fx dx equal to integration a to c fx dx plus c to b fx dx, this can be written for any continuous function. Okay.
Yes.
Now,
Yes.
if furthermore, if that function is discontinuous at point c, then also we can write it.
Achha.
Okay.
Okay, that means in whenever it is discontinuous at point C, the correct procedure should be it is breakdown
Yeah,
at the discontinuous.
break it in two parts and you have to calculate. Exactly.
Okay.
Yeah. Okay, so let me share this screen now. So can you see my screen?
Yes, sir.
Yeah. So yeah, we are using Mentimeter again, and so there will be a code. I think many of you should have known this right now, and you have to give the answer for this question. So for depending on the difficulty of the question, I will assign you 5 minutes or 10 minutes for that question, and then you have to submit your answer in Mentimeter course, and then we will discuss stepwise solution. Okay, so I will discuss the solution with you. You have to interact with me. Okay, so yeah, so the first thing before starting the question, this second derivative test I have mentioned here. So someone also asked me this thing just now. So at first what we will do, we will find the critical points by solving the equation f dash x equal to 0. Suppose in an interval, I am trying to find local maxima or local minima. So if f dash x equal to 0, then that point is a critical point. So suppose at C, I am getting f dash c equal to 0. So C is a critical point. Now I have to calculate f double dash x and put C there. If f double dash c is strictly less than 0, then it will be local maxima. And if f double dash c is strictly greater than 0, then it will be a local minimum. And this test fail if f double dash c is 0. So, and in those cases where f double dash c is 0, we have to basically go through the behavior of the curve. So that thing I will discuss later. So, and there is something called a saddle point or point of inflection if the critical point, which is neither local maxima nor local minima. So there is an important point that if f double dash c is 0, that does not imply that it is neither local maxima nor local minima. It only implies that this test failed, but still that point can be local maxima or local minima. Okay, so let's go through an example. I think then will be clear. There will be 3-4 questions on this. So I will go to the first question now. Yeah, so this is the first question. A function is given, a polynomial function. So the statement 1 is the number of critical points are 3. Statement 2 is x equal to 1 is a critical point. Statement 3 is x equal to 2 and x equal to 4. Both are critical points. And statement 4 is x equal to half is a critical point. So basically you have to find all the critical points of this function. And the options are, so these are statements. So options are all the statements are true. Option 2 is statement 1 and statement 2 are true. Option 3 is statement 1, 3 and 4 are true. And option 4 is only statement 3 is true. So yeah, so this will require some time to solve. So I will give you 5 minutes to solve it. Okay. Then I will go to the next page where you can put your answer.
Hello, sir.
Yeah.
Sir, if the quiz is going to happen online, will there be both MCQ and MSQ question or only MCQ?
Actually, that is not decided itself till now. So maybe there is a possibility to only NAT type of questions.
Only NAT?
Only NAT.
Okay,
This is a possibility. I am not confirming this because
yes,
still we are not sure of on that.
okay, sir.
Yeah.
Hello, sir.
Yeah.
Sir, if it will happen in online mode, then how many questions will be there?
I mean, that depends on the timing of the exam, right? If so, till now,
Okay.
what is the talk going on? It will be a 45 minutes paper. So maybe 7 to 8 questions.
Okay, sir.
Yeah. Yeah. So should I go to the next page where you can give the answers? Have you calculated this critical point?
Yes, sir.
Okay. Okay. So I will go to the next page where you can give the answer. Then I will discuss this with you. Yeah. You can use the code and give the answers.
Go back to the first page. Just let me see the option.
Okay. Yeah. So option 1 is all the statements are true. Option 2 is only 1 and 2 are true. Option 3 is 1, 3 and 4 are true. And option 4 is only statement 3 is true. Okay. Yeah, so I am seeing most of you are giving option 3 as an answer, and some of you have given option 4 as an answer. So let me go back to the question again. Yeah. So option 3 is statement 1, 3, 4 and 4 are true, and some of you have given option 4 is true. That means only statement 3 is true. Okay. So whoever has given some option, can anyone on you wants to explain it to me?
Sir,
Yeah. Yeah, sure.
I calculated derivative for this first derivative.
Okay.
Then tried with all these options: x is equal to 1, x is equal to 2, 4 and half.
Okay.
Except x is equal to 1 for half, 2 and 4. That shows that first derivative is 0 if there exist the critical points.
Exactly.
According to that, the option 3 is correct.
Exactly. So first derivative is a 3-degree equation.
Yes, sir.
So number of solutions will be 3, and these are the solutions mainly 2, 4 and half.
So can we assume, because it is a quadratic equation, like it is not quadratic, it is a 4-degree polynomial equation.
Yeah.
So we can say that it definitely will have 3 critical points.
That is not necessary, right? I mean,
Like
some 3-degree, I mean, roots can be repeated, right?
yes.
Yeah. So we are not sure from that it
So
must be 3 critical points.
we have to find the solution by
Exactly.
equating f
Yeah.
dash x equal to 0.
Yeah. Yeah.
Okay.
Yeah. So yeah, option 3 is the correct one. So let me show you the solution. Yeah, so 16 of you have already submitted the answer. So yeah, so the I think f dash x you have calculated to be 2x cube minus 13x square plus 22x minus 8. Now you have to try to solve this equation, and if you factorize this, you will get x minus 2 into x minus 4 into 2x minus 3. So that will give you 2, 4 and half are the solution. So option 3 is correct. Okay. So yeah. So have you solved this question? Can you give this? So this will help us to create a data. Okay. So I think many of you have solved it, and some of you have partially solved it also.
So this question,
Yeah.
in f double dash x means in second derivative, if I put all the critical point value, the function value of f double dash x is always greater than 0. That doesn't mean, that means this function do not have any local maxima, a local minima.
So have you calculated f double dash x?
Yes.
Okay, and you are getting everything is greater than 0.
Yes.
Okay, so I have to check it whether are you telling it, I mean, are you solving it correctly or not. So if it is greater than 0, then everything is minima. That is true. But it's a degree 3 equation, right?
Yeah.
I
No,
mean, degree 3 equation. So 3
degree 3 is in first derivative, second
that's
derivative.
right. Second derivative will be degree 2 equation.
Yeah.
So
it's a increasing function, right? So
yeah, that's true. It's an increasing function.
there will be only no turning point, or
so you can plot this function and see it. So what will be the second derivative of this?
It is 6x square. Then minus 26x.
So whatever you are asking, this is my second question. The same thing.
Where?
The second question you can see, right?
Okay.
So the second question is exactly asking what you are calculating.
Okay.
Okay. So I will tell this answer after you solve this. Okay.
Okay.
Yeah.
Yeah, got it. I made a small mistake in
I think you have
calculation.
calculated it wrongly.
No. While I am putting value and calculating, I made some mistake.
Yeah.
Sir, how many questions are we going to cover in this session?
9 questions are there total.
So can you open the answer?
Yeah. So basically this problem is easy. You know f dash x from the previous
No. The Mentimeter code
yeah.
portal where we can answer.
Yeah, you can answer.
So can I just see the options again?
Yeah, sure. First option is only statement 1 is true. Second is 2 and 3 are true. Third is 4 is true. And 4 is 1, 3 and 4 are true. Okay. Yeah, so I am getting 3 answers now, 1, 2 and 4. Okay, so let me go back to the question now and see what is option 1, 2 and 4. So option 1 is saying only statement 1 is true, and option 2 is saying statement 2 and 3 are true. Okay, so if you remember that f double dash x, I mean if c is a critical point, then f double dash c should be less than 0. If it is less than 0, strictly less than 0, then it is local maxima. And if it is strictly greater than 0, then it will be local minima. So we have to just put the values 2, 4 and half there in f double dash x, and we have to see that whether those are positive or negative. Okay, so can someone explain it to me? Which one are actually maxima and which one are minima? Any one of you?
So x is equal to 2 has value which is negative.
Okay, so at first tell me what is f double dash x?
F double dash x is 6x square minus 26x plus 22.
So 6x square minus 26x plus 22. You have to put the 2, 4 and half in there, right?
Yes.
Yeah. So what is f double dash 2?
F double dash 2 is coming negative.
So it will come, I think, minus 6, right?
Yeah.
Yeah.
I
So
calculated the value. I can't see it just now.
uh,
X equal to 4. There was the positive value was coming.
some
And
positive
x equal
value.
to half was also positive value was coming.
Exactly. So that means 4 and half are local minima and 2 is local maxima, right?
Yes, sir.
Yeah. So I think you have got this answer now. Yeah. So this is the f double dash x, and you can see the values here also written. F double dash 2 is minus 6, f double dash 4 is 14, and f double dash half is 21 by 2. So there are 2 minima and 1 maxima, right? So now let us let me stop share this thing. Okay, so before stop this, let's take this poll. Have you
Sir,
solved
I
it?
just have a one small doubt.
Yeah.
Actually, answer I got, no issue. But I just try to visualize where is the maximum point and minimum point. That means, as per our calculation, it is coming. There is 2 maximum value and 1 minimum value.
Exactly.
Sorry, 2 minimum value and 1 maximum value. And the maximum minimum value point is 2, 4 and half.
Yeah.
But when I am plotting this graph, means function, original function f of x, and try to figure out this point, I am not getting the same point, sir. Although 2 and 4 I am getting,
okay,
but the minimum value, the maximum value at this half, I am not getting, sir, in curve.
At half, I think it is minima, right?
And
at
at half,
4 it is minima. At 2 it is maxima, right?
Yes, but in where should I put this? Means which curve I should consider, f dash x or f of x?
No, it is the for the original function.
Original function.
Yeah.
So
Actually,
then,
I was going to show you the graph of that function now.
Okay, just show.
Yeah.
Okay.
So let us see how the graph actually looks like. Okay.
Yeah.
So let me stop share this thing now. Yeah.
Are we expected to draw the graph or
no. So in this case, I think you can do it algebraically totally. Okay. So let me go to GeoGebra.
Sir, can I ask one question?
Yeah, sure.
The local minima means first the slope is negative and then slope is going to become a positive, correct?
Local minima. So local minima is slope is then negative and then it will be positive. Yeah, right.
Like a valley. And opposite is for the maxima, correct?
Maxima. Yeah.
That means second slope will be the second derivative, no?
Exactly. That's what we are calculating.
Thank you, sir.
So yeah, so the function was x power 4 by 2, right?
Yeah.
X power 4 by 2. Then it was
minus 13 x cube by 3 by 3.
Okay.
Plus 11x square.
Plus 11x square. Okay.
Minus 8x.
Minus 8x. Yeah. Right? So
yeah.
This is the plot of the function. Okay. So you can see this is your point 0.5, that means x equal to half. Okay. So there is a turning point and this portion, the slope of the curve changes, right? What just now I forgot his name. So he was saying that the slope of the curve is changing from negative to positive, right? So it is a minima at 0.5, that is x equal to half. Then again there is a turning point at x equal to 2, as you can see. Okay. And so there is a turning point and this is a maxima. So here the slope changes from positive to negative. And again we have a turning point at x equal to 4. So it will be again a minima. Okay.
Yeah.
So there are 3 turning points of this curve. And there are 3 critical points as we have derived, x equal to half, 2 and 4. And at 2 only it is a maxima. And at half and 4 it will give us local minima. And now can you say see from the graph what is the global minima of the curve? Can you tell me?
The second negative one, sir, which is having more depth.
I mean at x equal to what point we will get a minima?
X equal to 4.
Exactly. So there are 2 local minima, which is at half and 4. But at 4 we can see the graph is more negative, has taken more negative value. I mean it is the least value at that point. So x equal to 4 will be a global minima. Okay. So in between these 2 local minima, the global minima is at x equal to 4. And is there any global maxima exist?
No.
No,
sir.
Actually, this graph is increasing after x equal to 4 and it will go to infinity, right? So there is no global maxima.
Sir?
Yeah?
Can I ask a question?
Yeah, sure.
Sir, for global minima and maxima, we need to know the graph, right? Otherwise, we'll not be able to tell.
No, not necessarily. You will have to know this graph. So at first, if you remember, when in Maths 1 we have learned the end behavior of the graph, right?
Yeah.
So for this even function, I mean function polynomial with highest degree to be even. I mean it is a 4-degree function, right? So
Yes.
highest degree is 4 and that is even. So the end points will be either, I mean, depending on the coefficient of that degree of that term. So end point will be either positive infinity or negative infinity, right?
Yes, yes.
Yeah. So here the coefficient is positive, so the function curve will go to positive infinity. That we definitely know.
Okay.
Right?
Yeah.
For polynomial function, it is easy to see, but it's not necessary for any function, right?
That means, sir, can I conclude this thing in this way? Ki if a function having, if any polynomial having odd degree, then it cannot, it should not have any global maxima or minima.
Polynomial has an odd degree, then yeah, if we consider the domain to be whole R, then you can conclude it.
Yeah, domain to be whole R, then it cannot have, because one side it is going minus infinity, another side plus.
Yeah, but if you are given some particular domain, some restricted domain, then you can calculate it in that domain. That's why the boundary points are important. When we are calculating over whole domain R, there is no boundary points, right? I mean, it's extended to minus infinity to plus infinity, right?
Yeah.
Sir, that means that if I take the domain here, say from -1 to 5, then I can calculate the global maxima for it.
Exactly. Yeah. If we take -1 to 5, can you say me what is global maxima? I mean, asking you the same question what you have asked me.
At -1, it is the global maxima.
Exactly. At -1, at boundary point, it will be global maxima, not at 2. Okay. 2 is a local maxima, that is okay. But it take its maximum value at -1. I mean, you can check. You can substitute f equal to -1 here.
Sir, can you
can
repeat
substitute f equal
again?
to 5 here. So yeah, what I was saying, I mean, someone has asked that if we consider the domain to be -1 to 5 for this function, okay, I am restricting the domain to -1 to 5 and I am trying to calculate the global maxima in this interval. Okay, so I have calculated that 2 is a maxima. Now what I have to do, I have to check for the boundary points, that is -1 and 5. Now if you substitute -1 here and if you substitute 5 here, so you will get two values, and in between those values you can see that at -1 the function has taken a greater value. So the global maxima will be at -1 at this boundary point, not at 2. Okay.
Is it now in this curve it is fine because -1 will be the global maxima. Exactly. But is it necessary ki it is always lie on the boundary condition?
No, never. No. Not necessary. Yeah. I mean, just in this function, you can take, suppose my interval is from 1 to 3. Okay.
Yeah.
Closed interval 1 to 3. So in that interval, the global maxima is basically x equal to 2.
That means from boundary line, from boundary point, I will draw a straight line at x equal to that, parallel to y-axis, and wherever it cuts the function, accordingly the y value I will calculate and decide which one is global
you have
maximum.
To substitute that point, substitute the boundary point and check.
Okay.
So you have found some local maxima minima. So you have put all these values, whatever the local maxima or minima is coming. Then you have you have to check for boundary values. You have to put those boundary values and check what are the values of the function at that point.
Can we say like this? If it is a closed interval given, then only we'll be checking for boundary points. If it is an open interval given, we will exclude boundary points.
Exactly. Because for open interval, there are no boundary points. I mean, those points are not included, right? So you cannot check.
Yes, sir.
Yeah.
Sir, in the same function, can you describe the Riemann sums?
I will come to Riemann sum. Okay. So I have some questions there. I will come to Riemann sum. Okay. So let me go back there.
Hello, sir.
Yeah.
Sir, from graph, can we conclude what will be the saddle points and what are the maxima or minima?
Exactly. From if graph is given, then you can see. I mean, suppose this is the graph you are given. You don't know the function. Okay.
Yes, sir.
So you can see the where are the turning points of this function, right? So at those turning points, you can see the change in slopes, right?
Yes, sir.
So here at x equal to half, the slope changes from positive to negative. Sorry, from negative to positive.
Negative to positive.
So it will be a minima.
Hmm.
Similarly, at x equal to 2, the slope changes from positive to negative. So it will be a maxima.
Maxima.
So again at x equal to 4, you can see that. Now for saddle point, suppose I am giving you an example. So let's forget this one and this one, x cube. Okay.
Yes, sir.
So at 0, it is basically a saddle point. Okay. So if you calculate it at g dash x is 3x square, right? So, and at x equal to 0, the slope is basically 0, right?
Yes, right, sir.
Yeah, and
Sir,
if you
if a
calculate the
point is
double
not
derivative,
differentiable, then also it will be a saddle point, right?
yeah, that will be a critical point and it will be a saddle point. I
But
mean,
sir,
that's a little bit tricky. That is not true always. Okay.
But sir, if the equation is not given, then only from graph can we conclude what are the saddle points?
Yeah, you can see where the slope is not changing.
Okay, in close
I mean,
interval.
this 0 is not a turning point, right? As you can see.
Yes, sir.
I mean, after 0, the function is not decreasing again, then increasing. There is nothing like that. So at that point, I think the tangent is basically x-axis here, but in general, in the neighborhood of that point, the slope of the curve does not change. That is basically the indication of saddle point. Okay. Yeah. Okay. So.
Okay, sir.
Yeah.
Suppose, sir, in the same function, if somebody is taking a function y is equal to x square, it is a parabola which is touching the origin. But there at the point means origin.
So that is a turning point. So
turning point. So we can consider that point, right?
Yeah, exactly. So that is not a saddle point. That is a minima because it is a turning point. See, here the slope changes, but for x cube it is not the case. For x cube at 0, the slope does not change.
Yeah.
Okay. So that's the difference between saddle points and maxima minima. Okay. So from graph, it is easier to say what is saddle point.
Yeah.
Okay. Yeah. So yeah.
Hello, sir.
Yeah.
There was a question in activity 3.1, question number 6, that graph was given and also a function and asked what is there any saddle points or not. So if we only consider the graphs, can we conclude? Please take that question.
Okay, so with
3.1, question number 6.
Question number 6. Yeah. So these are given. Okay.
Yes, sir.
Okay. Then what is your question?
Saddle points.
So it is given that fx does not have a saddle point.
Yes, sir.
Assume you have to assume that fx does not have a saddle point. Then you have to check which one may be the correct option. Right. So if you see this curve 3, suppose you are seeing curve 3, so you can observe that there is a saddle point, right? At this position.
Oh, okay, okay.
So you can eliminate that option by seeing it.
But sir, in curve 1 at the upper bound, that is pi, That is also seems like saddle point and
Seems
also
like, but
curve.
you don't know. I mean, after that pi, what will be the behavior of the cup? You don't know.
But in the near value of pi,
I mean, you
that
just know
seems
only one neighborhood of pi. You don't know what comes after that. So you cannot conclude that that is a saddle point or not.
okay. Okay.
So
So
yeah,
we have to check both closed interval.
yeah, you have to check in the neighborhood of that. It
Yes,
should
yes,
be
sir.
include the left and right neighborhood, basically.
Okay, okay.
Okay.
Thank you, sir.
Okay. So let me go back to this thing again. So there are many questions. Yeah. So this is the third question. So this is on this closed interval what we are talking about. So a function is given. This is the piecewise function. So in the closed interval 0 to 50, some quadratic function is given, and closed interval minus 50 to open 0, a cubic function is given, and yeah, you have to calculate the local maxima or global minima for this. Yeah, so take 5 minutes to solve it, then we will discuss the solution.
Hello.
Yeah.
Sir, can I know the code to join in the Mentimeter?
So let all of them to solve this, then I will go to the next page. Okay. In a minute or two, I will go to the next page.
No, sir, I was asking about the code to join the Mentimeter.
Code to join the mint. Okay. Yeah, this code basically.
Thank you.
Okay.
Hello, sir.
Yeah. Yeah, tell me.
Hello.
Yeah, hello. Am I not audible? Hello?
Yeah, you are audible.
Yeah, so
Hello, sir.
yeah. Hello?
Hello.
Sushmita, I can hear you, but I don't think you can hear me.
Hello.
Can somebody tell her about this? Just in chat, put that.
Hello, sir.
Yeah. Hello.
Sir, the question you discussed, 3.1, question number 6. The question said that f of x does not have a saddle point.
So you have to assume that, and then you have to.
But and in the card 3, you said there is a saddle point, right?
That looked like a saddle point, yeah.
But the answer is card 3.
Is that?
Yes, sir.
Okay, so let me check it. Okay.
Yes, sir. The answer is third.
Okay, so let me check it. I will check.
Yes, that question I was asked.
Okay, okay. So let me check it.
Okay, sir.
Yeah, I will get that. Yeah, you can put your answers here.
So quiz 1 will have 3 weeks content, right?
Quiz 1 will have 3 week content, yeah. Yeah, that question has some problem. Okay, so we will fix that. Okay, that question.
Okay, sir.
Yeah, so whatever the curve is given, that definitely has a saddle point. So yeah, we have to fix it. Yeah, so let's go back to this question. Some of you have given option 3 and many of you have given option 1. So let's check. Yeah, so can you explain me? Some of you can explain me that.
Can I explain, sir?
Yeah, sure.
I did this using simple logic.
Mm-hmm.
I did draw the graph of the two graphs. One is quadratic equation, another is cubic equation.
Okay.
So from 0, I use the quadratic equation and left side cubic equation. So after that, I saw that the point is coming at 1 is equal to maxima. and because due to the quadratic graph, and after that all graph is decreasing except on the 0 because it is the some point of inflection look like, and so that is one is correct, at one is this local maxima above the global minima. Since right side is decreasing by quadratic way and left side is decreasing by that cubic way, so obviously minus 50 will be more down than that right side plus 50.
Yeah,
that's
nice,
logic.
nice explanation. Yeah, so is it clear?
So the second point, this x cube plus 3, from there, the minus 50 as a global minima, this point is not clear to me because I try to find the second derivative, it doesn't exist.
But then you have to check for, these are boundary points, right? Minus 50 and plus 50, these two are boundary points of that interval, right?
No, sir, if you take the first derivative of x cube plus 3, it will come as 3x square.
Exactly.
So x is equal to 0.
X is equal to 0 is only the critical point, right?
Only the critical point.
Yeah.
And then when you are taking this f double dash x, so it will come as some 6x.
6x, x equal to 0, then it will give you
so
0.
F double dash second derivative becomes 0.
Exactly. So at 0, you cannot conclude it from here, right?
Yes.
Yeah. Okay. Now, if you see, now what are the, so the only critical points for this is 0, but 0 is not in the interval, minus 50 to 0. So this 0 is open, right?
Correct.
So this x cube plus 3 portion does not have any critical point except the boundary point. So boundary point is minus 50, right? So, and for the first one, if you take the, if you try to find the critical point, what you will get?
1.
So first derivative is minus 2x plus 2.
Oh.
Right?
No, first is clear. From the first derivative,
no, that's why I am telling. So your function is this whole function, right? Is a two-piece function. So for the first piece, the critical points are 1. Right? Only one critical point, and another critical point will be at boundary, right? We have to check for boundary point also.
Yeah.
Okay. So now we get for this whole function, we get only one critical point, that is 1, and for that we can check the local maxima or minima, and for the global thing we have to check for minus 50 and plus 50, right?
Okay.
So
Sir,
at
is
minus
50 a local minimum?
No, because these are at the boundary point. So at boundary, it should be always global. I mean, if it is at all exists, then it is a, we can call it global maxima or global minima there. If it is actually global maxima minima.
Sir, if we put 50 in the double derivative, it comes as minus 2 into 50.
But you cannot put this endpoints as inside this f double dash. That's my point. Because critical points exist only in an open interval. I mean, those critical points which are only in the open interval, not the boundary points. Except the boundary points, we have to check this double derivative test. That is only for those critical points which are in the interior portion, not for the boundary points. Okay.
Sir, can you plot this graph in the graph and explain? Then it will be easy for us.
Yeah, I will do that. Yeah, I will do that. Yeah. Okay. So let me show you. So can you tell me the first? You can see this graph, right? So can you tell me the first equation?
Minus x square.
Minus x square.
Plus 2x.
Plus 2x.
Plus 3.
Plus 3. Okay. So let me delete this thing. And what is the second one?
X cube plus 3.
X cube plus 3. Okay. Sorry. X cube plus 3. Okay. So observe that this green portion, this quadratic portion is from 0 to this side, whatever we go, wherever we go. Okay. This is for 0 to close 50. This quadratic portion, this green function. And this blue function is for open 0 to minus 50, right?
Right.
Okay. So you can see that at 1 we have a local maxima. Okay.
Yes.
Okay. Now after 1 this function is decreasing, And also in this side, I mean, you can go to the negative side from 0 to minus 50. This function is again decreasing function. Okay. So there is a possibility that at 50 or minus 50, there is a global minima. Now, which global minima? Plus 50 or minus 50?
Yeah.
So one easy way, you can see that this is a quadratic function on right side and cubic function on left side. So definitely the cubic part will give you more negative value, right? So that will be your global minima. Or you can put minus 50 itself in the negative part, I mean x cube plus 3, and you can put plus 50 in this function, minus x square plus 2x plus 3. So, and if you compare these two, then you can see that minus 50 will be your global minima. Is it clear? And
okay.
you can put that value, you can put that value in f double dash only if you can find it as a critical point. Okay, only if you can find it as f double dash. Otherwise, you cannot put that boundary points in f double dash. Okay, so here only the
So we cannot put the boundary points in the double derivative any मतलब कोई भी condition में.
कोई भी कंडीशन में नहीं दे सकते. अगर सिर्फ f डैश x से उसका सॉल्यूशन आए तो उसी को तुम रख सकते हो f डबल डैश में. Is it clear?
Okay, sir. But sir, every time we have to check both the boundary points, right?
If some closed interval is given, you have to check for boundary points.
Then sir, for this second equation, x cube plus 3, where we won't get any f double dash because it is a
there is no critical point.
Right, no critical point. Then what is the significance? That means it is showing some inflection point. Is there any inflection point in this graph?
So you can look at this graph. So if you ignore this green function, I mean green curve from the left side, and if you ignore this blue curve from the right side, you can see that this function is continuous at 0, right?
Right.
Yeah, that this function is continuous at 0. Why?
Because the green, yeah.
So can you tell me what is the left hand limit? What is the left hand limit at 0? 3. What is the right hand limit?
3.
Again, it is 3, and at f0 is also 3, right?
Yes.
So these 3 matches. So at x equal to 0, this function is continuous. Now, can we tell me that at 0 is it differentiable?
No, because it is a sharp edge.
Yeah, exactly. I mean, from the using definition, can you tell me? I mean, you have to just calculate it. Okay. So if you calculate it, you can see the definition was limit x is tending to 0, fh minus f0 by h at 0. So if you calculate the right hand limit and left hand limit, it won't match, right? So in that case, you can see that this point is not a, I mean, differentiable point. I mean, at x equal to 0, this function is not differentiable. Okay. So when a function is not differentiable at some point, then also we call it a critical point, right?
Yes.
Yeah, then also we call it a critical point, but we cannot check it is maximum or minima by going to the second derivative because it does not come via that way, right? It does not come via f dash something is 0, right? So we can check f double dash 0. What is f double dash 0? We cannot check it because at 0 the function is not differentiable itself, right?
In other words, at point 3, it's a sharp turn.
Exactly, 3 is a sharp turn.
And no tangent can be drawn, right?
No tangent can be drawn.
Two tangents, right?
I mean, you can say it at this point. So two
tangents. At that point, no tangent is possible.
Yeah.
Exist.
Yeah. From left hand side, there is one slope, and from right hand side, there is another slope. That's the main issue. So
that is why.
Yeah, that is why it's, although it's a critical point, but it is not a saddle point. I mean, it's a sharp turn there.
Sir, this saddle point and inflection point is same.
Yeah, so there are many, I mean, in general, it's considered to be same, but some author defined it to be different way. But what we are considering here, saddle point and point of inflection are same.
Means I just tried, suppose this critical point is like what we are calculating from this function. Every critical point is helping us to find what is the maxima and minima of that function. In that way, if I try to understand what is this inflection point and saddle point wants to tell about us on this curve, what should I interpret?
I was discussing earlier, no? So saddle point is that point where the slope of the curve does not change in the neighborhood of that function, neighborhood of that point. I mean, that is not a turning point, basically. It is a critical, it is, we can find it by, yeah.
When you say change in tangent means slope from negative to positive, positive to negative, correct?
Yeah, exactly, yeah.
So it will go till 0, but never below 0. That's
exactly,
the point.
yeah.
Can I conclude, sir, this?
Which one?
This question, the point of inflection and saddle point.
So that's what I was telling. I mean, you are finding critical point, and I mean, by taking if the point is an interior point, you can check f dash that is 0. That's how we can calculate the interior critical.
No, sir, I want to tell Samit that the answer of his question. Can I explain?
Yeah, sure, you go ahead.
Yeah, Mr. Samit, that he was asking that this point of inflection, no?
Yes, right.
Yeah, point of inflection is nothing. It is the point on the curve where the concavity of the graph changes. If you
have not defined concavity or convexity, right? You are telling
graph change his curvature. That actually meaning of the point of inflection, where the double differentiation comes to 0. In the x equal to x cube graph you are seeing, no? Just before 0, a concavity is down, and just after 0, concavity is up.
Actually, I do not understand this concavity because this thing I don't know actually.
Yeah. So
okay. Then you will get later.
That's the point. Yeah.
Okay.
So we have not defined the curvature of a function or curvature of a, given graph. So yeah, what Kumar was saying, he is right actually. So where the curvature does not change, basically, just little bit.
And sometime in the curve, what's happened? There is a double differentiation is 0, but concavity is same, so doesn't change. It is the curve. So this too makes the little confusion, but it is the very clear idea. Once you will get that about curvature and concavity, your idea will be get clear.
Exactly. So for now, what I can tell you that if that point is not a turning point, yeah.
Okay.
Not a turning point, still f dash is 0. Still it is a critical point, but not a turning point. Then it is a saddle point.
Okay. Okay. Thank you, sir. Thank you.
So if you calculate f dash at that point is 0, but you can see that at that point the curve of the function is not turning. Slope change from positive to negative or negative to positive. That means it is not a turning point, but still it is a critical point because you have derived it from f dash x equal to 0. Then that point must be a saddle point.
Okay.
Is it clear?
Yeah. Okay.
Yeah,
I
so
understand.
This portion of this course, it is enough to remember. Okay.
Fine.
Yeah.
So.
Yeah.
Sir, can we say that all cubic polynomials may have the saddle point?
Not all cubic polynomials.
Because now if we see this x cube plus 3 at exactly 0, that becomes horizontal.
Yeah.
So
that may not be true always, right? Okay. We can construct some polynomial using cube, which is, all x cube plus a type of function is definitely a saddle point. There is a saddle point.
Chances with cubic is more. We can say like that.
Okay. Yeah.
Sir, can you tell what does double derivative give? Like first derivative gives the slope.
Yeah.
So what does the double derivative give?
You can tell me, what does the double derivative give?
Sir, is the value?
Yeah.
Is it the value of the tangent?
What? Slope of the tangent.
The slope of the tangent.
Can I explain this, Mr.?
Can we say like this that tangent is actually the rate of change of sort of, you can say, the distance. That is the change in y with respect to the change in x, and
That is
double
the slope of
derivative
the
is
function,
actually
right?
the rate
That
at
is
which
slope.
the rate at which the slope is changing.
Exactly,
That is
you
a
can
double.
say that. Yeah, yeah, exactly. Yeah,
Okay,
Kumar, do
thank
you
you.
want to say something, Kumar?
So there is a three way to express the double differentiation. First, you can tell that it is the rate of changing of the tangent,
Exactly.
in mathematical way. And second way, you can say that double derivative also gives you the point where the concavity is also changing.
So this concavity convexity part actually has not come here. That's why this may be difficult to some learners. Okay.
Yes. Yes.
So what you are telling in the first point, that is actually enough, I think.
Mathematically, this is the way of.
Mathematically, that is the how the
And
slope of the tangent changes.
Yeah, we can interpret also one other way.
Yeah.
Suppose there is a no, if you think there is a no meaning of double differentiation, because after giving the first differentiation, another, whatever the differentiated function, you can take as the function. If you take as this as the function, then double differentiation become the first differentiation of the previous function.
That's obviously, yeah, that is obviously true.
So this way also we can think further, and direct also can think further, graph we also think.
Yeah,
so
but
there is
for that you have to know what f dash x throughout the domain.
Correct.
Yeah. I mean, if the original function is not differentiable at some point, then it will be difficult. Then f dash x will not exist at that point. So f dash will be not continuous at that point. So again, f double dash also will not exist, because you know that differentiability implies continuity, right? So if it is not continuous, then
throughout that, if the throughout, yes.
Okay. So
So I had a doubt in activity question 3.2.
Okay.
It's regarding to this global maximum and local maximum.
What is the doubt? Can you tell me?
So there is a function given over here. F of x is equal to x by n plus n by x. And it's told that n is both a local minima as well as a global minima.
Okay.
So, sir, can you explain me how is it possible that n is both a local as a global minimum?
I mean, I will show you this example again. Okay, I have deleted that now. Okay, suppose I am considering this function only. Okay, this function. Okay, so what is this local minima? Sorry, local maxima?
It's 1.
At x equal to 1. And what is this global maxima?
No, 4.
What is this global maxima?
4, right?
I mean, the maximum value is 4, but x equal to 1 is itself the global maxima, right?
Yeah.
So whatever the local maxima is, it is exactly the global maxima. So for some function, it can happen.
Okay, sir.
Right? Yeah. Okay.
Sir?
Yeah.
Sir, in the 3.1, in that same question, I got that n is a local minimum. I got that part. But how it is becoming a global minimum, I mean, it is given, but I cannot conclude that by deduction or something. I cannot conclude.
Okay. Okay, so I will come back, but there are 6 more questions are there. I think.
Okay, sir.
You can go ahead, and after that, if there is time, I will get back. Or otherwise, you can post. I mean, have you joined in the Discord?
Yes.
Are you following the discussion in there, going in there? So I think if you can post your questions there, then I will reply there. Okay. If you just post your question there, I will reply on that. Yeah.
Thank you.
So, yeah. So here is the explanation what I have explained this question. Okay. So have you solved this question? Just a quick poll.
Sir.
Yeah.
So in this question, why 0 is not included for global maximum calculation?
Not in domain.
I mean, at 0, the function is not differentiable at first. So although it is critical point, it is neither local maxima or local minima. Now, if you can calculate f0 is 3, right?
Yes, sir.
So that will not give you the global minima. The global minima is at -50. That is much negative. right?
No, so suppose for the first equation, 0 is treated as a boundary point.
You can take it. I mean, f0 is 3, right?
Yes.
So it is not giving you the global maxima or global minima.
Sir, but when we differentiate and equate it to 0, we are not getting 50 as a critical point, right? We are only getting 0. So how come 50 be the local mean?
That's what I was explaining till now. No, this minus 50 and 50 is boundary point, right? So whenever you are you have given some closed interval, you have to check the boundary points for also for the maxima and minima.
0 is also a boundary point, right?
Yeah, 0 is also a boundary point.
So
I mean,
how
the
to find
function is
global
not differentiable, so it is a critical point. I mean, the definition of critical points is either f dash c is 0, or at that point the function is not differentiable. So at 0, we have checked the function is not differentiable, right? But f0 is 3, and f of 1 is, I think, 4, 5, or something like that. 5, yeah. 5 or 4, yeah. So
we
I mean,
should,
that is not a minima nor a maxima, right?
So how to find global maximum for this function?
So you tell me, what is global maxima?
Now, out of all critical points and boundary points, whichever.
You have to check at which point it is the maximum value is coming. So at 1,
f
the
of x.
maximum value is coming, right?
At f of x.
Yeah.
Sir, boundary points can only be global minima or maxima, right? They cannot be local minima.
I mean, for boundary points, we generally do not talk about local thing.
Okay.
Okay.
Yeah.
Yeah.
Thank you.
So we should substitute them in the f of x, right?
You should substitute in f of x. Yeah.
Okay.
Yeah. Okay. So, but whenever some boundary points is given, you must have to check it for maxima or minima. I mean, if you have to find out what is global maximum or minima. Okay. Yeah. So, can you solve this one? Fx is a function given as sin x plus cos x plus 5. Which of the following is the maximum value of the function in the interval 0 to pi? So you will find some interior critical point by finding f dash x equal to 0, and also you have to check. So you have to find the maximum value that may be a global maxima. So you have to find also for the boundary points 0 and pi. For that also you have to calculate it. And among all these points, I mean, whatever the critical points you will get by solving the equation f dash x equal to 0, and also these 2 points, among all these points, which is the maximum value, that will be the maximum value of the function. That is the global maxima. Okay. Okay, so option 1 is root 2, option 2 is 5, option 3 is root 2 plus 5, option 4 is 2. So I can go to the next slide so that you can give the answers here.
Can you go to questions, sir?
Yeah. Okay. Okay, should we go to the option? Yeah. So many of you have given option 3 as the correct option. So some of you can explain it.
Yes, sir.
Yeah.
Can I?
Yeah, sure.
Yeah. It is the simple, simply differentiate and equate first difference in itself.
So
Because function itself is the continuous and last term 5 is nothing for shifting the graph up and down. So
what you have said?
Yes, I just did only the function. I have taken sin x plus cos x. I found the maxima.
Okay.
And whatever the maximum will get, I will just shift the graph 5 up.
That is, yeah, that's true.
And second way also we can solve if without differentiation, if I can combine sin x plus cos x in one trigonometrical function, then it's it.
Okay. So you are using some formula there.
Yeah, sin x plus cos x in either sine or the cos. So after that we can get one function.
Yeah, that is also true. So here we can definitely solve it by finding what is f dash x. So it will be cos x minus sin x, and if we equate it to be 0, yeah, so we'll get x equal to pi by 4 is the only solution in the interval 0 to pi, right? So, and we check for that point we can check f double dash x. So if we can calculate f double dash x, that will be minus sin x minus cos x, and if we put pi by 4 there, we will get a negative value. So x by 4 is a local maxima. Now for 0 and pi, you can check what are the values there, and for pi by 4, as I have checked, the values is root 2 plus 5, and for 0 it is 6, and for pi it is 4. So you can see that 4 is less than 6 and less than root 2 plus 5. So root 2 plus 5 will be the maximum value of the function in the interval 0, 4. Okay, so here also we can see that local maxima is nothing but the global maxima. Okay, here at the boundary we are not getting any global maxima or minima. Okay. Okay. So how many of you have solved this? Let's take a poll there.
No, how did that 1 by root 2 plus 1 by root 2 became root 2? It's 2 by root 2, right?
2 by root 2. So what is 2 by root 2? It's root 2, right? 2 you can write as root 2 into root 2. So 1 root 2 get cancelled out.
Okay.
Okay. So yeah, so some of you have asked earlier, what about this Riemann sum? So one kind of question I have given in practice assignment and also in graded assignment. So estimation of area of a graph in the interval AB using Riemann sum taking n subintervals of equal length on AB. So if we take a partition, suppose some interval is given, closed interval AB. Now I am taking a partition on that, and the partition of this subinterval are of equal length. So I am dividing it. So the length will be b minus a by n, right? Because if the interval is AB, then the length of that interval is b minus a, and I am dividing it into n subintervals. So each length will be b minus a by n. So first point will be x naught is basically a, x1 will be a plus that length, x2 equal to a plus 2 into that length, and so on, right? So eventually at nth position we will get a plus b minus a by n into n, that is n will cancel up and a minus a will cancel, and that will give us b. So we have divided this interval AB into n subintervals. And now what is the meaning of estimating area by taking the left endpoint? So there we can do many things. So we can take the left endpoint, we can take the right endpoint, or we can take any midpoints also to calculate the taking the midpoints mean value at the midpoint of that function. And if we complete the square, that is basically length into breadth. So that will gives us this type of value for each one. Suppose we are taking the left endpoint. So here left endpoint means we are starting with x naught, x1, and we will finish till x n minus 1. We will take FA to be the length. So FA will be the length at the left, and 1 by n will be the breadth. So the area of the rectangle will be FA into 1 by n. Similarly, for the second subinterval, this is the f of that x1 will be the length, 1 by n will be the breadth, and so on. So we'll go till n minus 1 because we are taking the left endpoint. Similarly, for the right endpoints, we'll start from x1 because for the first subinterval is basically x naught x1. So x1 will be the right endpoint and x naught is the left endpoint. So as we are taking the right endpoints, so f of x1 into the breadth is 1 by n, and we will finish till fb, that the nth point, and the breadth is 1 by n. Now the estimating the area means if we take n tending to infinity, we will get the area. So basically what n tending to infinity mean? So 1 by n tends to 0. That means we are taking the subinterval goes to 0. That will be the actual area under the curve on the interval AB. Okay, so this limit is nothing but the integration of fx dx from a to b. Okay, so let us see a problem on that, then I think it will be clear. Yeah, so this is a problem. The function is 2x plus 3, the interval is 0 to 3, and we have to calculate the estimate the area using Riemann sum. Now the first statement is I am dividing this 0 3 in 3 subintervals. Okay, so the subintervals are 0 1, 1 2, and 2 3. Okay, now I am taking the right end points of the subinterval for the height of the rectangle, and we calculate the area of that. Similarly, by taking 3 subintervals, I am taking left end point for the second statement and midpoint for the third statement. And the fourth one, I am dividing this 0 3 in n subintervals and taking the right end point and then taking n tends to infinity. What will be the area? So there are 4 statements, and the options are all 4 of statements are correct. Only statement 4 is correct. Only statement 1, 3, and 4 are correct, and only statement 1 and 3 are correct. So I think this will take some time to solve. So let's take 6 to 7 minutes to solve this.
Sir, can you show the previous slide once?
Okay. Yeah. So basically what we are doing, we are dividing the interval in some sub-intervals, and when we are approximating the area from the left hand points, that means suppose I am dividing the area into the partition, dividing the interval into the partition x0, x1 to xn. Then when we are taking the left hand points, then our value of the function will be, the area will be fx0 into 1 by n, fx1 into 1 by n, to fxn minus 1 into 1 by n. That is from the left hand side. And from the right hand side, it will be fx1 into 1 by n till fxn into 1 by n. So that will be the right end points of the subinterval. Okay. And for
Sir,
the
what is
midpoints,
xi star that is used in the
here for the left hand point, the xi star is nothing but xi minus 1. Sorry, xi. And xi star for the right hand point is xi plus 1.
And sir, midpoint?
Midpoint will be xi plus 1 by 2.
Average of subtle.
Yeah.
Okay.
Yeah.
And sir, we also saw another kind of, graph where sir was taking a trapezium kind of, the X star was a trapezium. What will be the value for that?
So yeah, that's the point. I mean, here in case of Riemann sum, it does not necessary that we have to take the subintervals into same length. I mean, we can take any partition of that interval and we can calculate the estimated area. Okay, but what our aim is to find the actual area of under this curve, right? The given function that will give us some curve, and what will be the area under the curve on that interval, right? So we have to ultimately make this partition as finer as possible, right? So if I am distributing it in n interval, then each of the sub interval we are trying to make it limit to 0, right? That is our aim. So yeah, definitely we can take any type of sub intervals, but it is always better to take sub interval of equal length, that is 1 by n, and then taking n tending to infinity. So this problem will give you that idea. So that is the main idea behind the Riemann sum. Okay, so those trapezium or rhombus, anything you can choose, except without using this rectangle thing, but that will not help you to find the estimated area. I mean, that will complicate your calculation only. But eventually it will give. But in general practice, we will take this kind of thing.
I mean, in the graph, it was seeming that the trapezium was much more accurate than the left hand and the right hand. I mean, the part that was forming due to that trapezium shape. I mean, it was seeming that it was much more accurate than the other this left hand interval or right hand interval.
What is trapezium shape here?
I don't know the exact formula of that, but while in the GeoGebra, while sir was showing us that left hand, using the left hand interval or the right hand interval, and he was also showing that midpoint interval, and along that he also showed us that some trapezium shape of that small strips, they were like the shape of trapeziums.
Okay.
So when he was taking lot of trapeziums, that trapeziums were.
That's what my point is. I mean, you just take any partition,
okay,
and any geometrical shape there, any rectangle or trapezium or anything, and if you take more finer subintervals in this given interval, then eventually you will be close to the area under this curve. I mean, whatever the geometrical shape you will take.
I mean,
But when you are computing by hand,
yeah,
okay, computing by hand means algebraically you are computing. It is always better to take rectangle, because for rectangle we know the area is basically length into breadth.
Length into breadth. Yes.
That is much easier to calculate.
Okay.
Right. So that this problem is basically a motivation for that.
Okay, sir.
Okay. Okay, so have you calculated it? I mean, should I go to the next slide? Hello?
So you can show the options.
Yes, sir.
Yeah, okay. Yeah, so you can put your options there.
So can you show the question once again?
Yeah. Okay, so option 1 is saying all the statements are correct. Option 2 is saying only statement 4 is correct. Option 3, only 1, 3 and 4 are correct. Option 4 are only 1 and 3 are correct. So yeah, can someone wants to explain it? So I am seeing there are huge variety there. So yeah, option 2 and 3 got almost same vote. So 2 was only statement 4 is correct, and 3 is only statement 1, 3 and 4 are correct. Yeah, someone can explain it, right? What about the first statement? Let's go take the first statement. What we have to do for the first statement? Yeah.
F1, F2, F3 addition.
So the partition is basically 0, 1, 1, 2 and 2, 3, right?
Yeah.
So the length of each subinterval is 1.
1.
And left hand points are 0, 1 and 2.
Yeah.
So f0 into 1 plus f1 into 1 and f2 into 1, right?
Yes.
Yeah. So what we are getting here?
15.
Is it? So have I calculated
We
it
get
wrongly?
21.
So
21,
it
sir.
should be 21. So you can see the first one is f1 into 1, f2 into 1 and f3 into 1. That means 5 plus 7 plus 9, that will give me 21 square units. So the first option is correct. Okay. Now for the second option, when we are taking the left hand points. So left hand points means 0, 1 and 2, right? So again, if we calculate it, we will get 15 for the left hand points, right? So it will give us 15. And for the midpoint, so midpoint of 0 and 1 is half, midpoint of 1 and 2 is 3 by 2, midpoint of 2 and 3 is 5 by 2, right? And if we calculate it, I think we will get 18, right? So I can now see that 1 and 3 is already correct, right? So what about the last one? So for the last one, we are dividing 0, 3 into n subintervals. So our subinterval will look like 0, 3 by n, 2 into 3 by n, that is 6 by n, and so on. So there should be dots in the middle. So on to 3 into n minus 1 by n and 3n by n, that is 3. So these are my subintervals. Now I am taking right hand points of this subinterval to calculate the estimated area. So I will start from x1. So 3 by n into f, 3 by n, and 3 by n into the second x2 will be 6 by n, and so on, right? So I can take 3 by n common, and I just put the value of this function, that is 2x plus 3, right? So have you done this one? Any of you?
Sir, as n tends to infinity,
Yes,
can we apply
yes.
direct integration?
But you can
Without
apply direct integration, but
without going through these steps.
yeah, that you can apply. But I
Get the
have given this
expression.
problem to motivate this definite integral. What is the motivation behind the definite integral? To showing that I am giving this solution. Yeah, you can definitely calculate the, I mean, that is the last note I have written here. Observe that the values we obtain is same as the definite integral 0 to 3, 2x plus 3 dx, right?
Yeah, sir. In exam, there is time constraint also.
Definitely, in exam you have to do it definite integral if this n tend to infinity case comes, right? But I am showing how these values are equal. Okay.
Okay,
So
sir.
you can see that if you put the values and take this common 3 by n common outside, then you can get 2 into 3 by n, and you take 1 plus 2 plus till n, right? That is sum of n natural numbers. So you will get n into n plus 1. Then you can distribute this n there, and you can get these values. Now with n tending to infinity, this 1 by n will tend to 0, and you will get 9 plus 9, that is 80. Okay, so you can check this calculation. I am not explaining it here again. Okay, so yeah. So I think option 1, 3 and 4 is correct. I mean statement 1, 3 and 4 is correct. So option 3 is the correct one. Okay. So let me go back. So yeah, option 3 is the correct one. Okay. So I think who have given this wrong option, they can understand why this option 3 is correct now. Okay. So yeah, now there was a concept of antiderivative in the lectures. That is basically the function. If we take a derivative of that function, we will get f dash x. So when we integrate f dash x dx, then that will give us fx and some constant, and that constant is called integration constant or constant of integration. Okay. So yeah, so this is a question. I think this question is from activity question. Fx is x cube minus x square plus x. Fx, capital Fx is the antiderivative of fx, and f2 is also given as 6. Then you have to find the value of fx. So can you calculate it? So it should not take much time.
Sir, in last question, can you explain how we are getting left endpoints?
Okay. So that I can explain. Okay, so if I finish this problem and then go back, then it will be okay?
Yeah, sure.
Yeah. Just remind me once, okay? After this problem.
Okay.
Yeah.
Sir, I had like a question.
Yeah, tell me.
Sir, integration was discovered before Riemann sums. Then what was the need for Riemann sums?
Integration was discovered before Riemann sum means?
So
I mean,
like
historically.
it was, yes.
Is that?
Yes, sir. It was discovered in the 17th century, and Riemann sums were discovered by Burt and Riemann in 18th century.
Okay. Okay, so I have to see it. I am not sure on that. I mean, historically, which one came first and what was the motivation? If I see Riemann sum first, then to integration, then for me the motivation is clear.
Yes,
why that should come. But what you are saying, I have to verify it a little. Okay.
Okay, sir.
I am not sure on that.
So options?
Yeah. So yeah, you can give your options. Okay, so we are getting option 4 as the correct option here. Now, can someone explain to me what you have done here?
This is find C question, right?
Yeah. So you have to just make a integration of this function, right?
Integration and derive and find out C.
Exactly.
And put 2 in everywhere.
Exactly. Yeah. So this is what I did. So I took the integration of this function, and C is the constant of integration. Now f2 is given as 6. So if I take the derivative of this capital F, I should get fx, right? So the constant, if there is a some constant, then that will be 0. So in this, together with this integral, there is some constant in fx. Now I put f2 equal to 6 in this equation, and then 8 by 3 will come out. Okay. Okay. So yeah, I think most of you have solved this problem. Just give me a poll here.
Although it worked out in this particular equation, it may not be the case always. You may get two different C's for some functions.
I mean, here particularly F2 is given, that's why it's working.
Yeah, I'm not talking about this equation. Generally, if you cannot generalize, right, there could be like two different C's or cases.
Exactly.
Two different C's where F2 will become 6, and equation could be something else.
Yeah. Okay. So who has not solved this question, I think now you can get the essence of how to solve this. Now let me go back to this Riemann sum again, as someone was asking. Yeah. So suppose I am dividing this 0, 3 in 3 intervals. So my partition is 0, 1, 2, 3. So my intervals are 0 to 1, 1 to 2, and 2 to 3. So when I am talking about the left sum, then I am taking 0 is the left end point of the first interval 0 to 1. 1 is the left end point of the interval 1 to 2, and 2 is the left end point of the interval 2 to 3. So I will take those points as my left point, and I will consider the rectangle and I will calculate the area of those rectangles. That is the motivation for the left end points. And for the right end point, what we will do? So 0 to 1, 1 is the right hand point, 1 to 2, 2 is the right hand point, 2 to 3, 3 is the right hand point. Okay. And I will take that point, functional value at that point as the length, as the height of the rectangle, rather we can say, and the length of the sub-intervals are 1 in each case here, because the length is equal here. And I can calculate the area by taking the product F1 into 1. Then for the second rectangle, the area will be the length of the subinterval 1 into f of 2. And for third subinterval 1 into f of 3. That's how I am getting the right hand points subinterval, I mean area, estimating the area by taking the right hand points of the subinterval. Is it okay?
Yes, sir. Thank you.
Yeah. Okay. So this one is also okay. Okay. Yeah. So now I have come to the question where the function is given and I just have to calculate the area under this curve. So I think this is quite easy. You have to calculate the definite integral -1 to 2. Okay, so option 1 is 3, option 2 is 6, option 3 is 9, and option 4 is 1. So 3, 6, 9, 1 are the options. So you can put your options here. Oh, so many of you are saying it's option 2. Option 3 also is coming. Okay. Okay. So I am skipping this a little bit because there is lack of time. So yeah, so I am taking integration -1 to 2 fx dx and x square plus 1. So it will give me x cube plus 3, and for 1 I am getting x. So I am calculating in -1 to 2. So if you just put the values there, then I think you will get a equal to 6 if you calculate it correctly. Okay, so option 2 is the correct one. So yeah, this one was an easy one. Let's put a poll here, a quick poll. Okay. So yeah, many of you have solved it. This function. So this is, I think, also from your activity question. So you have to find the value of this integral, which is from minus 2021 to 2021. Okay. So should I go to the option page? I will solve it. I mean, for this problem, you
Yes,
don't
sir.
have to calculate the function totally, I think, you know. Yeah. You put your option, then we will discuss this. Yeah, option 3. Option 2. Okay. So can someone explain me this question, how to solve it?
Hello, sir.
Yeah, Sushmita, tell me.
Yes, sir.
Yeah.
Sir, if we put x equals to minus x, and that is f of x equal, we get f of x equals to minus f of x. That is, it is an odd function. And for
Exactly.
odd function, integration value will always 0.
Not always 0. When I am taking integration from minus a to a,
Yes,
in
yes,
that case it is 0.
correct,
Yeah.
correct. Yes.
Yeah. Yeah. So it's an odd function. You can check it as cos of minus x is cos x, and sine of minus x is minus of sine x. And
Sir,
yeah.
Can we do it this way that integral from minus a to plus a is actually integral from minus a to 0 and 0 to a, and minus a to 0 is exactly minus of a to 0. So both
Exactly.
the integrals will cancel.
That is basically the proof of why this odd function integration is 0.
Yes, sir.
What you are telling is basically the proof of that thing. Yeah,
Okay, sir.
exactly. You are right. You are right. Yeah.
Fine.
And similar fashion, you can also prove that minus a to a fx dx, if fx is even function, then it is 2 into 0 to a fx dx, right? Because those will add up.
Okay, sir.
Yeah. Okay. So yeah. Okay. So there is a checking where minus f of minus x is minus of fx, and then the integration is 0. So option 3 is correct. So have you solved this question? Okay, I think most of you have solved this. So yeah, this is the last problem of this session. So I have two functions, f1x and f2x. f1x is 3x squared, and f2x is, so f1x is this parabola which is facing upward, and f2x is 4 minus x squared, which is facing downward, as coefficient of x squared is negative. and you have to find the area which is enclosed by these two parabola. I mean the area which is pointed in the figure, and that area is A. So, and you have to find what is 3A. Okay, so let's try to solve it. Yeah, so can we go to the option page? You can put your options here. So two of you have put, yeah, option 4. Okay. Yeah, so can you explain me the process? How can we solve this? Someone please explain the process.
Calculate integration for both the equation and subtract one
integration
from the
from where to where?
Integration from minus 1 to 1.
Where have you find this -1 and 1?
Equating it to like intersection points.
Exactly. So at first we have to calculate the intersection point, right?
Yeah, intersection points, roots are -1, 1, and from there you calculate the area and subtract it from one another.
Yeah, exactly. So yeah, so
it
at
will
first we
come
have to
out
calculate.
as it will come out as 16 by 3, but you have to do a 3a, so the 3 will cancel out.
Exactly, yeah. So at first I am getting this point of intersection -1 and 1, and the second step is so this integration will give us area under the curve. So for the first function you can see this is the area under the curve, and the first second function this is the area under this curve in -1 to 1. So if you take this one, first one as A1 and second one as A2, then A2 minus A1 will give us the area in between them, right? So this is the diagram representation of this thing. So yeah, we'll get area to be 16 by 3 and 3A will be 16. So I think you will get this question. So have you solved it? Yeah, for the last few problem I have given less time, that I know, but at least we have discussed the problems. So yeah, you can write here how was the session in 3 words. These are all for some data. I mean, how we can improve it further. Okay, so while you are writing this, can you do me a favor? I mean, someone has asked the question that why Riemann sum came later and integration came earlier. Still, why Riemann sum is needed, right?
Yes, sir, I did.
So can you post it in discourse once so that
Okay,
I can
sir.
remember and give you the answer?
Okay, sir, I'll post it.
Yeah. And someone also pointed out a mistake in activity question, right? The saddle point thing.
Yes, sir.
Who was that? He or she is still there?
Maybe.
Yeah, so that one also, if you just mention in discourse, then it will be so that I can get a reminder.
So can I ask a question of the activity?
sir.
So can I ask one of the activity questions?
Okay, so let me stop this. Yeah, thanks.
So activity 3.1 question, it was.
So what's your doubt?
So there was a question that there's a graph given.
This is activity 3.1, right?
Yeah, so can you just scroll down a little?
Which question?
So below. So just scroll down it. Yeah, so this one, the fourth one. Sir,
Okay.
here we are considering this part of the graph.